Hey guys, today we're going to look at lesson 4.7, and we're going to talk about congruence in triangles that overlap one another. So we're focusing on phase 2 of our proof process, and that is using the given and the picture. So we're going to focus on that picture for a little bit. Some reminders here. The pictures that we have come across so far are the hourglass, where we use vertical. And we've also seen some triangles that are stacked, where they share that side, and that was known as reflexive. We're using the reflexive property. So we're going to add 2 more pictures to our toolbox. And the 2 pictures that you see here, example 1, I call this the Xbox picture. That's what I refer to it as. And the second example here, I refer to this as like the transformer symbol. There. So what we want to look at in each of these pictures are, what do the triangles share? And before we get into what they share, we're going to look at example 1, talk about it. So the 2 triangles that we're focusing here are BAC and triangle DCA. Right now in this picture, we have 1, 2, 3, 4. We have 5 different triangles represented in this picture. And the 2 that we're going to focus on would be BAC, which is this left-hand triangle, and DCA, which would be this right-hand triangle. And both triangles, they share this bottom side. This bottom side here, AC. So that is going to be another picture where we use reflexive. Okay, they share a side. They're very similar to the stacked triangles. Okay, for our second example, again, we have these triangles that are overlapping, so they can be sort of confusing. We want to highlight the 2 that we're using. So the first triangle, WXZ, which is this left-hand triangle. Our second triangle will be YXV, our right-hand triangle. Now, when we ask ourselves, what do the triangles share? A lot of times our focus is on the side. So here, the triangles, they do share part of a side. Okay, they share part of a side, but we want them to share a whole side or a whole piece of information. And here, it's not a side that they share, it's an angle that they share. They both include this angle X. Okay, this is also known as reflexive. So up until this point, our reflexive has always been a pair of sides. But we can also have angles that are reflexive in our pictures. Okay. So again, we have our 2 new pictures here to add to the hourglass and the stacked triangles, and that is the Xbox and this transformer symbol. Okay, so the first proof that we're going to work with here is the transformer symbol. And when we're working with proofs that have overlapping triangles, one thing that I recommend to you guys is to draw the two triangles separately. So we have ABE, that's one of the triangles that we're working with. That would be this left-hand triangle. And I'm going to redraw this. Doesn't have to be a perfect match. But here we have that left-hand triangle redrawn. I'm also going to repeat the process with the right-hand triangle, triangle CBD. There we go. So again, this is your right-hand triangle. And by doing that, it'll make it much easier for us to add information into our picture as well as figure out which shortcut we are using. So now we're going to go through our proof process. We'll go through the phases. Phase 1, label the given. Angle A is congruent to angle C, and side AB is congruent to side BC. So we write that in our two columns, as well as we're going to put that information in our separated triangle. So we have A and C, those two angles are congruent, as well as AB and BC. We'll move into phase 2, where we use our given, which we don't see any terms up here. So we'll move on to the picture, which we just discussed that in this picture of the transformer symbol, we're going to say that this angle here, B, is being used twice, once in each triangle. So to add that to our two columns, angle B is congruent to itself, angle B, and that is through the reflexive property. Now we move into phase 3, find our shortcut. And our shortcut here, we have two angles, the included side. So we do have enough information to prove that triangle ABE is congruent to CBD by the shortcut angle side angle. All right. And in our last proof for today, we're going to be working with the X box. So when we have these overlapping triangles, we're going to separate those triangles. We're going to redraw those pictures. We have the left-hand triangle here, ABC. And we also have the right-hand triangle here, which would be DCA. Okay. So once we have those triangles separated, we'll go through our proof process. We'll start out by labeling the given. Side BA is perpendicular to AC. Side DC is also perpendicular to AC. And BC is congruent to AD. So the only statement that we can add in our picture here is the congruency. BC and AD, they both receive one tick mark there. Moving to phase 2, which is using our given. Here we have perpendicular mentioned twice. So we want to use definition of perpendicular, where we have BA is perpendicular to AC, so we have a right angle that is formed there. We also have DC is perpendicular to AC. So for our second statement, we're going to say that angle BAC is equal to 90, as well as DCA is equal to 90. All right, we move to our picture. We have this X box where this side at the bottom, side AC, is being shared. That is the reflexive property being used, where AC is equal to itself. And we're also going to label that in our separated triangle. So I'm going to put 2 tick marks for AC in both triangles. And we move into phase 3, which we look for our shortcuts. We look for our 3 things. We do have an angle, a side, and a side. That angle is 90 degrees, so we are able to use HL from our previous lesson. So our fourth and final step, triangle BAC is congruent to triangle DCA because of our shortcut HL. All right. So take a look at the practice and the homework checks. If you have any questions, please get in touch with me. Have a good day.